Okay, so I decided to make a little video on bolts and screws. So I kind of think this information to be helpful if you're a machinist or getting into machining, or if you go in to buy bolts at a store. Just kind of helps to know the classification of bolts and kind of what you're looking at and what you're looking for, and kind of know what you're talking about. So if you want to get technical to start off with, a bolt's not really considered a bolt until it has a nut with it, and it's just usually considered a screw until it has a nut with it, obviously. So machinists get kind of technical about that, so you probably just want to know that. Or if a machinist keeps calling something a screw, you'll know what he's talking about. So this is a classification for a thread, and it's kind of long, but once you break it down, it's not too bad. So the 1/2 inch is your major diameter of a bolt, of a 1/2 inch bolt, for example. I just chose 1/2 inch. It can be 1/4 inch, 5/16, it can be whatever. I just chose 1/2 inch because it's pretty common. So the number after that is going to be threads per inch. 13 is pretty common. So for Unified National Course thread for 1/2 inch. So the Unified National Course, this is what these abbreviations mean. That's the type of thread. Again, that can be Acme thread, Brown and Sharp. There's hundreds of different kinds of threads. So you need to keep that in mind. Then the number after that's going to be your class of fit. Now, class of fit is kind of important to know. We'll go down here and look at this. This is your class of fit. So you've got what's called a 1 is going to be your loose fit. So example would be like an Acme thread for a vice thread. It's pretty loose, got a lot of play in it. Most of your bolts and screws are your standard fit that you buy at the store. And then like the ones you might get from a machine shop, you can have them machined so they're an accurate fit, so they're going to have a little bit better, a little bit tighter tolerances, I guess is a good way to explain it. So just kind of know that it's a 1 through 3, 1 being loose, 3 being accurate. So it just kind of depends on your use, what you need to choose and what's appropriate for what you're doing. So you're either gonna, after your class of fit, you're either gonna have an A or a B, and that basically means your external or internal fit of it. And A means external, B means internal. So just remember that. Now after that, you're either gonna have an RH or an LH. LH is obviously left-hand thread. RH would be right-hand thread. Okay, after that, you're going to have what's known as your length. So it would be 3 inches, 2 inches, whatever it is. After that, you have your grade. Now, grade 5 is pretty common. It does gets the job done for most of what people use it for, these threads for. You can have a grade 8, which is a little bit higher tensile strength. So just something to keep in mind. But grade 5 is pretty common, so I just chose 5. But you can get lower grades too, so just keep that in mind. So we'll talk about metric threads here. I left a lot out. There's a lot more to it, but this is just general knowledge, and just so you know what you're looking for when you go to the store or to a machine shop. M would be your metric. 10 is kind of your major diameter in millimeters, not centimeters, or just to keep that in mind. And then after that, it's your pitch. Now, pitch is the same thing as what we would consider threads per inch. Just two different ways of doing it. There's both work. Just two different methods of measuring threads in a distance. Kind of is a good way to say it. And I'll show you on the next page what pitch is. It's from the crest to the crest of a thread, and I'll tell you the parts of a thread, so don't worry. You'll kind of get a better understanding of that. Okay, after that, I was going to talk about the tap drill chart right here. Now, this Starrett tap drill chart is about the handiest thing to have. It's got just all kinds of information on it if you know how to use it and read it. I mean, it's got on the back here, it's got your metric threads, and then it's got your pipe thread sizes and all that, and it goes up to 1.5 inches. So one thing you need to realize is the tap drill chart's based on 75% thread engagement. So basically that means engineers have figured out that any more thread engagement is probably not worth it, especially the time it takes into machining such a high tolerance item, because your bolt is going to shear at before the threads give out on 75% thread engagement, if that makes sense. So and I'll show you how to read this here real quick. So we'll choose a 5/16 by 18 thread. So that's kind of the coarse thread for 5/16 right here. And so like let's say we needed to pre-drill a hole for a 5/16 by 18. We would go and choose a letter F drill bit and drill it out with a letter F, and then tap it with a 5/16 by 18 tap. So just that's pretty easy. Sorry it's kind of blurry, but kind of easy to read if once you get the hang of it. There's numbered drill bits, there's decimal drill bits, there's fractional ones, and there's lettered ones. So just keep that in mind, so you know what this means. So kind of get a little complicated. So the next thing I want to talk about is taps. You've got your tapered tap, which is used to start a thread, and basically it's I guess you could say it's a little bit more chamfered at the end, for easier starting in a hole. And then you've got what's called a plug, and it's used to basically follow up after the taper tap to get a nicer thread. Basically that means at the start of the thread there's a little bit less chamfered at the start on that tap, I guess is a way to say it. I mean, once you see them, you'll know what I'm talking about. When you get into like a machine shop, or if you go out and buy them, you'll kind of start to see the difference between the 3 different kinds here. And bottoming tap is used to like let's say you're in a blind hole. Like let's say you've got a 3-inch plate, but you only need to drill 1 inch into it and tap it. You'll start off with a taper tap. You'll go in there until the taper tap bottoms out, and then you'll pull that back out, take a bottoming tap, and run the bottoming tap in there until it bottoms out, and you'll have the most amount of thread you can get into that 1-inch depth, I guess you could say. So it's just used for more like blind hole tapping and stuff. Now you can get into like dies. You got a couple different kinds of dies. You got like solid dies, which are more for like chasing and reconditioning a thread. Then you've got like adjustable dies. You can produce thread on a cold rolled steel, not hot rolled. The reason why you want to use cold rolled is always made undersized. Hot rolled is always made oversized, if that makes sense. So the reason why this is important, because you don't want to have it like, let's say you go out and buy like 1-inch hot rolled. It's on a tape measure, yeah, it's going to show 1 inch, but you throw a micrometer on that, it's going to be a little bit over 1 inch. And you're gonna, when you go to use a die on that, you got a higher possibility of ruining your dies or just wearing them out quicker, and because you're cutting off a lot more metal, and it's just not going to thread into the nut part of it very good. So you always need to use cold rolled, because it's always made undersized by like 3 to 5 thousandths usually of the diameter, so you can thread it easier, and it will always thread into a nut easier when it's undersized. So just keep that in mind. Use cold rolled steel for threading. So, okay. Now we'll talk about parts of a thread. So, this is kind of a not the best, picture drawing kind of guy, but hopefully this will work. Okay, this is the parts of the thread. You've got your major diameter, which is outside to outside. Your pitch diameter is kind of like the halfway point here between the minor diameter and the major diameter, kind of like your pitch diameter here. Then we'll go over here to this side first. This is called your root, the very bottom of your thread here. And then you've got your pitch diameter, which is from your crest, and this flat part on top is called your crest. And that's where the metric thread measures off of. It's from pitch. It's from crest to crest is what they're measuring on the pitch diameter. Just so you know. And then you've got your thread angle. Unified National Course has a 60 degree thread angle. There's 55 degree thread angles. There's all kinds, because like I said, there's hundreds of different kinds of threads out there. And if you've got a lathe, you can have a lot of fun making all kinds of different threads, and making nuts and everything to go with it. So just keep that in mind. So like I said, the top of the thread is called the crest. You've got what's also known as your single depth. Then your helix angle, which is kind of like half the thread angle in a way. Then you've got your thread thickness, and that's kind of like your from here to there, right there. And there's all kinds of equations that when you go to make a thread, you'll do a lot of math to figure all these out for a certain kind of thread that you're machining, so you can make sure you make the thread the correct way and to the tolerances you need to. But this is just extra information. Just know your pitch diameter, your major diameter, and your thread angle, and what the crest and root is, and that's probably good right there. And I was just going to show you a couple different kinds of threads. There's the American Standard National Standard thread, which is like the unified thread. Either nut will thread onto either of these. We go with the unified thread now because this has a rounded. This is more on a unified thread. It's rounded right here instead of flat. And on the American National Standard thread, it's flat on the root here, and on the crest, it's flat. But either nuts will thread on just fine. They both have the same 60 degree angle right here. So the reason why we go with the unified thread is when you get into like metallurgy and stuff and weld analysis, having more of a rounded thread is better than a sharp angle right here at the root, and that just makes a better thread, I guess, is what you need to know. So then you've got like an Acme thread. That's like your vice threads. It's kind of square, more square kind of. You got like a British Standard Whitworth thread, and the Brown and Sharp Warm thread, and square thread, and then you got your International Metric thread. So I mean, there's a lot of threads you can keep. There's lots you can keep going on and on. But those are just some common ones. But like I said, you're going to run into your unified thread the most and your International Metric thread the most. That's the two that I would be most familiar with. And so hopefully this helps you out. Just get one of these. These are handy for what most people do. Good to have out in the field when you're working and stuff. So hopefully this helps you out.